In this video, I introduce a rectified flow for generative models. Rectified flow is trained with least squares optimization procedure, which avoids the instability of generative adversarial nets, the intractability of maximum likelihood estimate methods, and the subtle hyperparameter decisions of the denoising diffusion models. Given two empirical observations, x0 sampled from a distribution on pi 0 and x1 sampled from a distribution pi 1. The rectified flow induced from x0 and x1 is an ordinary differential equation on time t between 0 and 1 as shown here, which converts z0 from pi 0 to z1 from pi 1. The velocity field v is said to drive the flow to follow the direction of x0 and x1 of the linear path pointing from x0 to x1 as shown here and here, as much as possible. By solving least squares regression problem as shown here, this is the target and this is the prediction with xt calculated from x1 and x0, where xt is a linear interpolation of x0 and x1. A flow dzt equals to v is straight if zt calculated from z1 and z0 for any t between 0 and 1, namely v is a constant as shown here for following each path. A single Euler step update z1 equals to z0 plus v can generate z1 from z0. The rectified flow induced from x0 and x1 is denoted by z reactive flow. Reflow uses the rectified flow operation recursively to yield a sequence of rectified flows z key plus 1 from rectified flow with z key as a z0k, z1k induced from x1, x0, x1 is the key rectified flow. Reflow procedure decreases transport cost and makes the path of flow more straight. The straightness of learned flow is defined as here and explained in this figure. SZ0 means exactly straightness. One step of reflow can already provide nearly straight flows that yield very good performance when simulated with a single Euler step. After opting the keys rectified flow Z key, the inference speed can be further improved by distilling the relation of Z0k and Z1k into a neural network to directly predict Z0k and Z1k without simulating the flow. For a neural network T caret, the loss function for distilling Z key is expressed in this formulation. Distillation approximates the coupling Z0k and Z1k, while the rectified flow yields a different coupling Z0k plus 1 and Z1k plus 1 with a lower transport cost and a more straight flow. Distillation is applied only in the final stage when fine-tuning the model for faster one-step inference. As shown here, this is the pseudocode of a rectified flow. And this is the reflow module, and this is the distilling model. For more details, please check with these references. Thank you. Bye.